Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. Now, what you're about to see is a pre-recorded training session we did over in the United States. But be assured that a lot of the material that we cover is really applicable to any automotive application. So just be aware that yes, it is a lot of North American vehicles, but a lot of the same principles apply over in the UK as well. Now, if you have any questions, if you're watching this during the premiere, you can just leave it in the chat. We'll be monitoring that. And if you're watching this after the premiere, then just feel free to leave a comment underneath the video, and we'll get to those as we can as well. So my name is Jason Gabrenas. I'm one of Snap-on Diagnostics technical trainers. I've been in the training department since 2013, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep at Snap-on, so I had a group of about 30 different franchisees I worked with, as well as the shops that they service, in order to help everyone get the most out of their diagnostic needs. Then before I did that, it was 8 years at Subaru, so I worked in a dealership, and over time, I guess, I just became that default diag guy in the shop. So I always ended up having the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that had come into my bay. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. All right, so our topic today is we are continuing on our OEM-specific ADAS training journey that we're taking this year. And this week we are up to General Motors. So General Motors, much like anybody else in the industry, they use radars, they use cameras, they use ultrasonic sensors. They might even use very similar ones to some other brands do. I know there's only so many cameras out there and only so many types of radars and whatnot, but they use radar for their adaptive cruise control, blind spot monitoring, front and rear cross traffic alert, cameras, front and rear view, 360 view. They also do a little bit of the distance sensing for their cruise control, some model years, using the front view camera as well, which is a little unique. And then for ultrasonic sensors, of course, they use that for park assist, and some models do have also what they call advanced park assist, where it can help you get into a parallel parking type situation. One other thing that is unique to General Motors is they use those sensors on the car or trucks, and they use what we call sensor fusion. So they take inputs from multiple sensors on the vehicle, and they use some processing and allow the vehicle to have a function called Super Cruise. So on certain roads in North America, you are able to use this Super Cruise function, which is a LiDAR map data that they use. So instead of, some manufacturers have been trying to figure out how to put LiDAR on their production vehicles and use that for the automated driving and so on. What GM did instead is they sent out a fleet of cars with LiDAR units on, like the roof and stuff, drove around the roads and then mapped them that way. And then once they get to a certain chunk of information, they upload it to the server, and then the server downloads it to the car, and then the car can then use Super Cruise in that part of the world. So that's kind of what they're doing. And we'll look a little bit later. We're going to look into it, and it's quite the map that's covered. So there's other manufacturers out there that are doing a very similar thing, but it just seems like GM has its a little further along than maybe some of the other manufacturers. But we'll talk about that a little bit later. So let's talk through our little case studies on our vehicles. So the top selling vehicle in North America for General Motors is the Silverado, the Chevy Silverado, the GMC Sierra, twins there. And the highest selling model year in the last 12 years, it was 2015. So that is our representative for this. And in this vehicle, it has two cameras, one in the front, one in the back. 8 parking sensors for park assists. And then it also, on some, this was kind of a weird crossover year, so maybe late versions or certain option codes, also use radar for distance sensing cruise. They use a little bit of it with the camera, and then they also have some with distance sensing cruise that comes up. So the front camera, of course, is just mounted in the little thing near the mirror. That's got a big shroud up near the mirror. It's kind of up high on the windshield, like most vehicles have nowadays. And then if we were to go in the scan tool, we see the front view camera there. And then it is a functional test to do that. And the front view camera learn is available. And one important notice that's right off the top: starting the front camera learn procedure will delete all the learned values that are in there. So once it's started, you have to finish it in order for the camera system to operate properly. So if you don't go through the entire procedure, it's going to fail, maybe give you a code, and it just won't work the way as designed. So if we're going to do this, we got to make sure we're going to do it. The following conditions are necessary and helpful to reduce the time needed to complete the front camera learn procedure. At this stage, you need to verify if these conditions can be met. They will be displayed again when you're requested to drive the vehicle later. So if you can't do any of these in the location where you're at, then you don't want to start this procedure until you can meet these criteria. So ensure the windshield is clean. You need to be able to maintain a vehicle speed greater than 38 miles an hour or 60 kilometers an hour. Drive on a straight road with visible stationary objects on both sides of the road. Drive during daytime and good weather. Avoid changing lanes. The learn process will take approximately 5 minutes, during which the lane departure warning indicator will be illuminated amber. When the indicator changes to green, the process is complete. So, for example, if it's nighttime or if it's raining or whatever, I wouldn't be able to do this right now, so I would not want to hit continue. But let's assume that everything is where it should be, so we'll hit continue. And then we would start to drive the vehicle now. And it's going to remind you of the parameters that need to be met. Then once it's done, make sure the indicator is changed to green before choosing continue. So once it's done, it's going to be amber, 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 and then the indicator will turn green. When that's done, hit continue, and then that'll finish the relearn. Right. So it's simple enough. Drive it down the road. And we will see as we go through this course this evening that seems to me GM is the easiest manufacturer to do ADAS calibrations on, because it seems like they're all dynamic calibrations and there's not a single target that I've seen in my research. Granted, there may be one out there for something, but I haven't seen it yet. And, some manufacturers for the cameras, they have 3 targets they have to use and you have to space out. And so there's no chalk lines and plumb bobs and strings and chalk or anything like that. It's just, let's drive the vehicle under these parameters and it'll fit and it'll do itself. Related to the lane departure system, which the camera operates, and I know multiple manufacturers have this. It just so happened they had the little drawing in there in the same article. And this was actually the first time I had experienced that in a rental car one time. So I had a Suburban or Tahoe or something. And we were driving along and kind of drifted over the line a little bit. And all of a sudden my seat vibrated on the right side. I'm like, whoa, what's that? Oh, I went over the line a little bit, right? So that was the first time I had experienced it, and it was in a GM SUV. So that's just kind of sticks in my head, I guess. Now pretty much any vehicle that has lane departure warning has it. But, back then it was a novelty. Anyways, front radar couldn't find for this 2015 model year was no drawing from GM from this. And like I said, they do use the camera for the distance sensing cruise control. But if you were to compare it to, say, a Suburban or a Tahoe, it would be right down in this area right there on the driver's side, on the end of the frame behind the bumpers where it would be. And distance sensing cruise control is an option in the scan tool, as we can see. And then there's a distance sensing cruise control module learn. And this is going to be a very similar process to the camera. So start the learn procedure, we'll delete the learn values, just like in the camera. Once the procedure has been started, it must be completed. Driver information display will show a service driver assist message during calibration. Green vehicle icon indicator will flash while on learn. Do not back out of the procedure or press any other buttons until the calibration is complete. Following conditions are necessary and helpful, so it should be 10 to 30 minutes or until calibration is complete. Vehicle speed greater than 56 kilometers or 35 miles per hour. Avoid extreme acceleration or decel. Follow one or multiple vehicles. Typical vehicle traffic is fine, but vehicles 30 to 50 meters or 100 to 165 feet away are most effective at decreasing the calibration time. Drive on a straight road with many stationary objects at the side of the road. Then we hit continue and it would go. Then we wait till the green indicator stops flashing as we're driving. Then we hit continue. And then in this case, they want us to also activate the cruise control by setting a speed. Now, theoretically, safety-wise, once my icon had turned to green, unless I had somebody sitting in the passenger seat doing this for me, I would pull over in a safe area, then hit continue, and then pull back out to drive. And it says activate cruise control by setting a speed. Did the cruise control activate? Yes or no? That's kind of its pass-fail, whether or not it worked. We'll just say yes. And then procedure was performed successfully. We're done. Easy enough. Rear camera, no calibration available for that. It's just a camera, and it sticks in the back by the tailgate there, just underneath the tailgate. And then the park assist system, the little sensors just clip into the bumper, pretty much like we've seen in pretty much any other manufacturer, and no calibration needed for that. However, we will see on a couple of these other vehicles, there is a calibration that might need to be done. But in this 2015 model in particular, not so much. Next one, we have the 2019 Chevy Equinox or GMC Terrain. They have two radars in this particular model, one both for blind spot monitoring and rear traffic cross traffic alert in the back. Camera, there's 5, one for in front. This is what they use the adaptive cruise control for. Also front view for sign and lane recognition, and then 360 view all around. Ultrasonic sensors, there are 6 in the front and then 6 in the rear. Park assist and advanced park assist. If there's advanced park assist, they'll have the 6. If not, they'll have the 4. Front camera, same deal. Got it up there on the top. And it's going to be very much the same procedure. But notice how we have a few other options on this menu, but we'll do front view windshield, functional tests, and then there's that front view camera learn we saw on the Silverado already. Rear radar, like I said, not much going on there. It just kind of bolts to the rear bumper on the inside. And then side object detection module left, we would go into. And go into functional tests. And then you can see there aren't any resets, relearns for it. It just kind of sits there and does its thing. But we can force the indicators, the audible alerts, haptic alerts to trigger, just to test them and make sure they're working. Rear camera, same deal. So it's a rear camera, no calibration necessary. And then the 360 camera. This was kind of interesting, I thought, because most manufacturers, they have some sort of a calibration procedure needed for it. And in this case, there isn't. You're basically just going to drive it along the ground and just make sure that the picture comes up. It just kind of hangs out in the mirror there, and that's it. And then as far as park assist, like I said, 6 across the front, 6 across the rear. So there's the usual 4 there. And then there's one on either side in front of the wheels. That's for the advanced park assist, if so equipped. And the advanced park assist, and that is the parallel park help, as I mentioned before. And also, when I go into the vehicle on the scan tool, it has me choose the RPO code. So that's the option code. So is it advanced parking assist with semi-automatic steering? Or is it park assist with rear sensors only, or parking assist with front and rear sensors? So I'm just going to choose that one. And then, of course, there's functional tests, which would be the beepers and buzzers. But a module setup in here, there is actually a parking assist sensor alert. So this is the first time we've seen it so far in this series where the parking sensors had a relearn necessary. So ignition on, engine off. Make sure no objects are within 50 centimeters or 20 inches of parking assist sensors. It's going to count down a minute. It's going to do some sort of something. Maybe trigger the sensors, I guess. Make sure nothing bounces back. Turn off the ignition and remove the key. Open and close the driver door. Avoid operating any accessories. Wait approximately 2 minutes for the vehicle to complete shutdown. So it wants to shut everything down. And it's going to give you a 2-minute countdown once you're outside of the vehicle. Once that's done, it says procedure is complete. So that's what it is. Couple minute wait, and we're done. Last vehicle we have is a 2016 Malibu. So in this case, it has 3 radars, blind spot monitor, and 1 for adaptive cruise in the front. It has 2 cameras. It does also, depending on the option code, like I said, it may use the camera for adaptive cruise control. Also has front view and rear view. And then 8 ultrasonic sensors on it, park assist and advanced park assist options on this. Front camera mounts to the windshield. It's going to be the same exact procedure we saw on the other 2 vehicles, so we're not going to go through it again. Same parameters and everything, right? So just do make sure, if you're working on multiple different models of these, that you do double check, because I have seen the speed change occasionally from time to time, depending on the year, make, or year and model. Not really make, but year and model. 37, 35, that sort of thing. It's not a huge change, but just be aware it may be different. So just follow it. Rear camera mounts in the trunk deck near the handle. No calibration needed. Front radar. It's going to mount behind the grill here, kind of behind the emblem. and just kind of shoot out from there. And that's going to be the same situation as we saw on the Equinox as well. So it deletes the learned values, got to drive between 30 and 50 meters away, that good weather conditions, that sort of thing. Same procedure. Rear radar, nothing really going on with that. Once again, we can trigger the alert indicators and such though. And then for the park assist, they're in the bumpers, of course. And in this one, inside the parking assist module, we have a CAN bus configuration learned. So there was a relearn for the actual sensor on the Equinox. And now we see on this Malibu, there's actually a CAN bus configuration relearn. Not a relearn of the sensor. So it's slightly different model to model. But I think you've noticed throughout these, and we're going to take a little bit of a dive into a newer model here in a minute when we go live. But pretty much since they started this, no targets, drive the car down the road. You do need a scan tool with the proper software in it. But if you have a Snap-on scan tool already included with the software, doesn't cost you any extra, and it's just there. So plug it in and follow the procedures. I think if this is going to be my first foray into ADAS reprogramming, recalibrating, I wouldn't mind doing a GM at all because it's pretty straightforward. You pretty much just put it in a learn mode and drive it. As long as you drive it within those parameters, it should only take a few minutes and it should calibrate itself. It's pretty smart system. So let's look live real quick. We'll talk about a couple different things. So here we are in our scanner. I'm not going to pull up the scanner quite yet. I'm going to look up Super Cruise first. All right, so we do have Super Cruise up here, the website from GM. So this was kind of interesting too. I didn't, until I first started looking into this, actually in more in depth. I knew it existed for quite some time, but didn't realize they built a green or a light bar into the top of the steering wheel. I maybe would have put it in like a heads-up display or something like that, but see just how it compares to the competition. Can do automatic lane changes, can do trailers. I wanted to see what roads there are, so I kind of zoomed in on Kenosha there, Snap-on headquarters. It looks like you might even be able to get pretty close to Snap-on headquarters with just using Super Cruise the whole way. Isn't that neat? If I zoom out to the North America view, you can see it's pretty much every major and state highway, even up in Canada, all the way up in Canada. It's pretty far. So yeah, we can see US and Canada available there. Rest of the world, not sure. I don't think they even have, yeah, it doesn't even go past US and Canada on the map. So imagine it's not available in other countries. Need OnStar service plan, and it downloads it. So it downloads the map to the car and then uses it. Now, the only vehicles it's on too is the SUVs, right? So Suburban, Tahoe, Traverse, Silverado EV, Blazer EV, and Equinox EV. So any of the EVs will have it. And you can read the limitations down there if you so desire. So let's look in this 2024 Chevy Tahoe, which would have that. And let's take a look to see there's considerably more options for ADAS stuff on this vehicle. So there's an automated driving mapping module. So that's where it would actually download that map data, that LiDAR map data to the vehicle. Front view camera system in the functional test. We have a front view camera learn, and look at that. It looks pretty much exactly like the one we saw on all the other vehicles. They haven't changed it since they started putting it on the vehicles, which is wonderful. Maybe they might be a speed thing. No, still 37. Oh, 37 miles an hour. The other one said 35, right? So it's close, but you just want to make sure. So I'm not going to go through that though, but you can walk through the procedure and just drive the vehicle. Also, with the Super Cruise system, you can take your hands off the wheel, but don't just open the paper or magazine or start playing in your phone or anything like that, because it has a camera that monitors you and makes sure you're paying attention. And if you're not paying attention, it disengages the system, so kind of defeats the purpose. Radar sensor modules, as we can see, the long range in the front, and then we have short range, left front, left rear side, right front, right rear side. So it's got a bunch of radars on it. 2, 4, 6, 7. 7 radars on it. That's where it does a lot of that's what does a lot of the work on it, I think. And then the camera system as well. Park assists, side object, I already went through that. Video displays, video processing modules. So all sorts of different things in here. But there is also another thing that I looked up here for the vehicle dynamic sensor offset calibration. So the vehicle dynamic sensor would be kind of like your yaw sensor, your roll pitch sensor, that sort of thing. It's kind of like a gyroscope. Doesn't require calibration often, but you do need to calibrate it when you replace it, or if you get this certain code. And the calibration procedure can be completed with a scan tool, but you have to go where you might not necessarily suspect you need to go. So it says select image processing module processor 2. So I wouldn't know necessarily where to find that unless, of course, I read through service information, but let's go in there and find it. So it's actually under here, under audio video, image processing module processor 2. And we go in there and we go into functional tests, and there's that vehicle dynamic sensor offset calibration. Place the vehicle on a flat level surface, remove all excess weight, ignition on, engine off. Gonna go through and it's gonna do it. It's basically like a 0 setting a reset. It just resets it where it needs to be. But it is not where you might think it might be, because some vehicles, yaw sensor or the pitch sensor or what have you might be in like the airbag module on some vehicles, and other modules on other vehicles. So knowing where to find these things would be very helpful. And with that, that is our short and sweet GM course. So like I said, not a lot of complexity going on with these vehicles. There's no targets. It's basically hook up the scan tool with your software, plug in where you need to go. There's a functional test for it. Drive the vehicle like it tells you to drive it. And a couple minutes later, it's done. So not terribly complicated. And with that, that's our time here today. So make sure you tune in for new diagnostic content every week. We'll be premiering a new video every Wednesday at 7 p.m. UK time, so make sure to check it out here on our YouTube channel. Please make sure you also subscribe, thumbs up, and ring that little notification bell so you'll know anytime we post new content. With that, time for questions. Now, if you have any questions, once again, if you're watching this on the premiere, just leave it in the live chat and we'll do our best to answer those. Otherwise, leave a comment under the video and we'll get to those as we monitor those comments as well. So I'd like to thank you for taking a little bit of time out of your day to learning a little bit more about how you might be able to be more efficient at diagnosing vehicles using some of the information that we've been giving you today. Hopefully we'll see you next week, and we'll see you on any of our other videos. Have a good week, have a good night, and take care.